In a previous video, we showed how to complete the square. And in one part of the videos, we proved that a plus b squared is a squared plus 2ab plus b squared. We used geometry to prove this result. Okay. In our case, we're going to prove that this formula in general. So here we assume that we have a square of side length x1 plus x2 plus xn. So this is the side length. This is the length of each square or rectangle. Okay, because we assume that they are different. Okay, so here this is the side length for each one. So therefore the side length is going to be x1 plus x2 plus xn. Okay, so we use these symbols instead of a, b, and c because a, b, and c, it's only the alphabet. They can't fit all the variables that we need. Okay, so the area, this is a square, so the area of this one is the side length, this one, which we're going to call a by itself. So the area is going to be a squared, which is going to be x1 plus x2 plus x3 plus xn times x1 plus x2 plus xn, which we can write as we know as x1 plus x2 plus xn squared. Okay, so this is the area, but this area we can think of it another way. So we can think of it as summing the area of these rectangles and squares. So here we have a square because its side length is x1. Here we have a square because it's x2 by x2, and here we have x3 by x3, and the last one we have xn by xn. Okay, so there are many techniques that we can use to find this formula. We can use many tricks to find the area. One way is that we can sum the area of this one here plus the area of this one. So I mean, if we just fix x1 and we keep multiplying, so the area of this rectangle is going to be x1 times x1 plus x1 times x2 plus x1 times x3 plus x1 times xn, and we move to the next rectangle, so it's going to be x2 times x1 plus x2 times x2 plus x2 times x3 plus the last one, which is x2 times xn, and etc. until we get the last one, which has area xn times x1 plus xn times x2 plus xn times x3 plus the last one, which is xn times xn. Okay, so this is one way we can sum up these rectangles. So the sum of the area of the square is this area here of this rectangle plus this one plus this one plus this one. We can also sum them using this way here. We can sum up using these rectangles here, these rectangles, these rectangles, these ones. Okay, the same manner. Okay, but there is another technique that we can use, and that's what we can see. Okay, we can sum the area of this rectangle, this square, as the area of the squares. Okay, so these are the squares plus the areas of the rectangles. Okay, and that's what we can do here. So it's going to be x1 squared plus x2 squared, etc. plus xn squared. So I'll sum the area of the squares. Okay. Okay. So what's left? What's left is the area of the rectangles. Okay. But note that here in this case we have x2 times x1, this one, and I skip this one because I don't want to repeat this one. So this one has one key idea, is that I skip this one when x2 is x equals to x2. That means when the index 2 is equal to 2. Here, when I sum up, because I already computed this one, I don't want to compute them again. So when I get to x3, I want to skip this one. So here, when I get to this x sub I, okay, so this is, let's assume that this is a square of side length xi. So the area here is xi squared. So here I'm gonna sum up, but I'm gonna skip this one here. Okay, because I don't want to compute this one. I don't want to compute xi squared because it's already here in this formula. So that's why I'm gonna fix this one here and sum up the j's. Okay, the j's are the columns. So here I can do this one plus the sum of xi times xj with I different from j. So this is the area. It's the area of the rectangle, the squares, plus the area of the rectangles. Okay, so if x is 1, so I'll skip this one and I multiply. So here x1 times x2, I skip x1. x1 times x2 plus x1 times x3 plus x1 times xn. And I move to 2. x2 times x1 plus x2 times x3, I skipped 2. So that's what we mean by this formula here. So now this formula can be written as the sum of x sub I squared. The sum squared, not the sum of the squares. So it's going to be the sum of the xi squared plus the sum of xi xj with I different from j. Okay? I can rewrite this formula again, but for me this means that the sum of the area of the square is the sum of the area of the squares plus the area of the rectangles. That's what it means here, and that's what we mean, and that's what we need. I can simplify this formula by treating the case I is less than j or I is bigger than j. But I don't want to do that. This is enough for me because I want to have the 2 here. I can have a 2 here. But that one requires that to notice that if we are here and I is less than j, the other one, the other area is the same. It's counted twice. So for instance, this rectangle here, when I compute it, it's going to be computed here. So it's twice. Okay, so but I can have the 2 here. I can rewrite this one as I less than j. Okay, and I have to add 2 here, but this is enough. I don't need to worry about this. The most important thing is that we can see how geometry can help us prove this result, and I hope this is clear enough. Thank you.